Assalamualaikum and good days. My name is Nuraini Amirah and today I will be presenting my individual project for TCG633 Bridge and Road Maintenance. The title of my project is Digital Pavement Condition Evaluation and Maintenance Decision Tool. This project focuses on developing a digital tools by using Microsoft Excel and Power BI to automate pavement condition assessment and support more efficient maintenance decision making. So, without further ado, let's begin with the background of this project. Before I demonstrate the system, let me briefly explain the background and objective of this project. Pavement condition assessment using PCI and IRI is commonly carried out manually, which can be time consuming and may lead to calculation error, especially when evaluating multiple pavement sections. To overcome this challenge, I developed a digital tools using Microsoft Excel and also Power BI. Although tools such as Python or MATLAB can be used, I choose Excel because it is more accessible, user-friendly, and widely used by engineers, which allowing the pavement data to be entered, calculated, and also managed efficiently without programming knowledge. Therefore, the objective of this project are to develop an automated PCI and IRI evaluation tool, generate maintenance recommendation automatically, and also visualize the result through an interactive Power BI dashboard to support faster and more consistent maintenance decision making. Now, I will demonstrate how the developed system works, starting from the Microsoft Excel. Okay, now I will demonstrate how the developed system works using Microsoft Excel. The system consists of several worksheets which are lookup, PCI input, compute, IRI input and compute, and also final decision. Firstly, this is a lookup worksheet which itself as a reference database for the entire system. It stores the severity factor where the factor is 1 and 2 and 3, PCI and IRI classification, and also maintenance recommendation. So as the maintenance recommendation, let's say PCI and IRI condition is good. So the action recommend is routine maintenance. Same goes to the good, fair, and poor. Instead of entering this value manually each time, the system automatically retrieves the required information from these worksheets from the lookup. So it makes the calculation more accurate and consistent. This is the PCI input worksheets where we enter the pavement distress data that have been collected during the inspection. The required information includes the pavement section, defect type, severity level, and area of distress. So once the inspection data is entered, the system automatically performs the PCI calculation. So for the PCI compute worksheets, this is automatically calculates the pavement condition index, or we call as a PCI, for each pavement section, for section 1 until section 10. And it also classifies the pavement condition into categories such as very good, good, poor, and also fair. And it generates the corresponding maintenance recommendation automatically. So this is the recommendation maintenance that have been generated from the condition. So in these worksheets, it eliminates manual calculation and improve the efficiency of pavement assessment. So as the calculation for deduct factor, it is calculated by multiplying area and severity factor. So after we got the value for deduct factor, we will have a value for PCI, which PCI value is 100 minus the deduct factor, and then we will know the condition of PCI. So here we have a condition for S1 is very good. So the maintenance recommendation is routine maintenance. Next is the IRI input worksheets. So here we enter the International Roughness Index, or IRI, that have been measured and collected from the pavement survey. So this is the IRI value for the IRI input. For the IRI compute, as we can see here, this system calculates the average IRI value and then classified the pavement condition and also generates the corresponding maintenance recommendation automatically. So using both PCI and IRI provides a more comprehensive assessment because PCI evaluates the pavement condition while IRI evaluates the riding quality. The condition of section is based on the average IRI. So we can generate the condition based on the lookup here. As you can see here, the section 1 RIR average is to 1.8. So it is between 0.2 RII. So the condition here is very good. And then it applies to the other section here. So we have the last worksheet here is final decisions. So this worksheet combines the PCI and IRI results. The system compares the maintenance recommendation for both assessment. Automatically select the more critical or worst case recommendation as the final maintenance decisions. It also identifies whether the recommendation is governed by PCI or IRI or both indicator agree, helping that engineer makes more reliable maintenance decisions. So for the worst condition, it evaluates based on the PCI or IRI condition. So let's say we have for section 5. Here we have PCI condition is good and IRI condition is fair. So we choose the worst condition between both condition, and then it will generate the worst condition between both PCI or IRI. So for the decision source, it generates from the worst condition between both PCI or IRI. Let's say here we have the worst one is under RIR condition. So the decision source is from the IRI govern. After all the calculations are completed in Microsoft Excel, the results are imported into Power BI where they are presented through an interactive dashboard for easier analysis and decision making. Now we go to the PCI by section. This chart displays the PCI value for each performance section. For section S1, S10 and S3, they have the highest PCI value which above the baseline of 85, and it indicates that they are still in a very good condition and only require the routine maintenance. Now we go to the IRI by section. This chart shows that the IRI value for each pavement section, which represent the riding quality of the pavement. A higher IRI value indicates a rougher road surface that may reduce driving comfort. Together with the PCI value, the IRI result help ensure that the maintenance decision consider both structural condition and user comfort. So the baseline for IRI assessment is 8.2. For the IRI value below the baseline, it means a smoother road, better riding quality, and generally acceptable. While for IRI value above the baseline, it means the rougher road and less comfortable for road users. Going back to the PCI value, if the value is above the baseline, it is a better pavement condition. While if it's a lower than the baseline, it means the poorer pavement condition. Next, we have PCI condition distribution. This pie chart summarizes the overall pavement condition based on a PCI classification. So this pie chart provides a quick overview of how many pavement sections fall into each condition category, which allowing the engineer to identify the overall condition of road network more efficiently. So let's say I click under the 30% PCI condition. It will shows that which section under the 30% and under very good condition. Next, we have a worst case assessment. This clustered bar chart presents the final maintenance recommendation for each pavement section. It based on the worst case analysis. The system compares the maintenance recommendation for both PCI and IRI assessment and automatically select the more critical recommendation as the final decision. So let's say if I click at the major rehabilitation, it can clearly identify that section S4, S7 and S8 require major rehabilitation, while for overlay, section S5, S6 and S9 require overlay, and then section S2, S3, it require crack sealing, whereas the section 1 and 10 required a routine maintenance. So this visualization help engineer quickly identify priority pavement section, allocate maintenance resource more effectively, and make consistent maintenance decisions. So for example, if I select section S4, the dashboard will filter all related visual instantly. This interact feature allow engineers to review the condition and maintenance requirement of a specific pavement section more effectively. So as you can see here, For section 4, under PCI value, it is under the baseline. For IRI value, it is above the baseline, and for the maintenance recommendation is major rehabilitation for section 4. Next, the final decision table. It provides a detailed summary of final maintenance recommendation for each pavement section. Besides showing the final maintenance action, it also indicates the decision source, whether the recommendation is governed by PCI or IRI, or when both indicator agree. So this allows engineer to understand the basis of each maintenance decision and provide greater confidence that the selected treatment reflect the most critical pavement. In conclusion, this project successfully achieved the objective by developing a digital pavement condition evaluation tool by using Microsoft Excel and Power BI. The system automatically calculates PCI and IRI values, generates maintenance recommendations using the worst case approach, and present the result through an interactive dashboard. This reduces manual calculation, improves efficiency, and supports more consistent maintenance decision making. Based on the analysis of 10 pavement sections, 2 sections require routine maintenance, 2 require crack sealing, 3 require overlay, and 3 require major rehabilitation. This result helps engineer prioritize maintenance activities and allocate resources more effectively. From a broader perspective, this tool contributes to safer roads by identifying deteriorated pavement section early, improve driving comfort through pavement condition monitoring, and also support sustainable pavement asset management by enabling timely and efficient maintenance planning. For future improvement, the system can be integrated with GIS for location-based monitoring, connected to a cloud database for real-time updates, and developed into a mobile application for easier on-site data collection. Thank you. That's all from me.